Okay, let's go. Time to wrap this up. I noticed this build has taken a lot longer than it should have uh, with the video. Um, yeah, so joining up only the board interconnects and then it's done. Uh, so pin headers, of course, you can get the exact length. I typically just use um, I think it's 40 pin headers and then um, yeah, cut them to length. Actually, for the males, I just break them the correct length. Um, so typically, I make sure to put these into each other so I don't mess up. Pull out the pin and then just cut where I pulled. Of course, you can be, clean that up a little bit. Nobody's gonna see it, but you know, it's nice to be tidy. Okay, put this one with the female header down. Now I'm going to change that on the other one, even though this board has holes that are offset. Actually, both the mounting holes and the pin headers are offset. It's still good practice to alternate them. Uh, Pokayoki, so monkey proof, even if I was, I don't know, an idiot, drunk, stoned, whatever, I could never plug in the board um, the wrong way around. So this one, panel PCB gets the female, and this side, the panel PCB gets the male side. Um, this is pretty obvious. Spin chip goes inside of the sandwich. Uh, it's always a bit fiddly. Oh, it appears that I have a 10 millimeter standoff. This should be a 11, so I will only tighten it ever so slightly. I have to avoid damaging anything. Actually, if I look at this, my um, screw is overhanging the plated hole slightly, so I'm a bit worried about that very fine trace that's running next to it. I have some PCB PVC washers, obviously not at hand, but I'll do it like this. If I don't have a spacer for the board interconnect, I typically just put the PCB flat on the bench. Make sure it's aligned so it doesn't overhang to the side, touching any other neighboring modules. See, still some gunk left here. So annoying. And then just solder it all in place. Heating up the soldering iron. Is always the exciting and the anxious part of the build. What did I mess up? Did I make any mistakes? Did I? Uh, but we'll find out. I have to run in 45 minutes from now, but There should be plenty of time to get this wrapped up, powered on. Oops. I cut my pin header 1 pin short. Bad idea. No clue how we got to that. Okay, we can use this for later. Okay. Oh. No, I have to find a female as well. I'll add that to learning cost. Making a mess. Okay, female down because this side is the male. M3 screw. Lining. Not too tight. Again, solder fumes. Use an extractor. I opened my window so I have a bit more ventilation. Murphy's Law will dictate that my neighbor will start mowing the lawn anytime. But we'll be out of here quickly. I want the joints to flow nicely into the holes. Nice and shiny joints. Okay, flip this around. This is slightly less convenient. Use a dead Arduino to flip it. Do it like this because I want to see that flow. This is amazing solder, by the way. This is by far the best that I have used. I don't think it's all too expensive. It's caster leaded solder from Mauser. The roll was actually gifted to me by somebody that uh, didn't want leaded solder. Yeah, I love it to bits. It lasted me for a long time. Quite a few builds done with this. A lot of modules that I really enjoy were built using this solder. But it flows very nicely. It has a rosin core, but doesn't leave residue. Doesn't dirty up the iron too much. And as I'm saying that, my iron is a little dirty. Uh, all in all, great solder. Can highly recommend it. I think the only thing that I would like for this to have a smaller diameter, because for SMD builds this 0.8 millimeters is a bit too much at once. But yeah, other than that, really can't fault it. Using a bit too much here. This is as good as it's going to get. I was wondering what's rattling here, but it is some unconnected or not fully tightened knurled nuts. On here, tight. Clean this stuff up. Let me use the multimeter to check for any obvious shorts between the power rails. Oh, I'll just try to make this out. Make sure this works. This works. What is this? Why do I see a appears to 760 ohms on both sides. 900 ohms. And this is worrying me a little bit. Maybe it shouldn't. Let's grab a little spider here. Let's grab the other one out of the case. See if what the values are there. See Allen key. This 3D printed case is nice. I just used M2.5 screws without any threaded inserts. It's actually, yeah, machine screws, so not any. I think they recommend some regular screws. I shouldn't loosen things that are so tight with the little ball end of the Allen key. Not the appropriate method. Okay, now the tension is off it. Just yeah, so this is my little fun case. I can take that downstairs or go wherever, just play with it. See, this is the previous version of the Sproom. You see, yeah, components, yeah, are oriented differently. I think the yeah, I got this board pre-assembled, very nice, pick and place. You see a slightly better alignment on all the components. On the other hand, this yeah, I think my work doesn't look too bad, and functionally it's the same. But yeah, let me measure this. This power supply. Maybe I'm worried for nothing. 0.9. Put this up here. You can check. 0.9. And 0.7. Oh, 0.7. It's very cheap and cheerful multimeter, but it serves my purposes very well. Oh, I noticed that the encoder multiplexer chip is quite a bit bigger on the DIY build. Makes a lot of sense. This other package doesn't seem too exciting to hand solder, and I will definitely yeah, make the barrier to entry a bit higher. Yeah, for people that are new to building. Move this, park this over here. Oh, camera auto zoom. I should turn that off maybe. There's still some rattling, but it's a nut that's not fully tightened. Okay, so let's give this little case some power. It needs some work. It's definitely not yeah, in its final form. But let's see what we have here. If there's going to be smoke, I'm gonna cry on YouTube. I know there was some kind of hype where people would be crying on social media. At least my daughter was watching something, but yeah, I'm not gonna partake in in this kind of stuff. I hope so. Probably no crying, but definitely some coarse language. Okay, as they say in Germany, or at least my mom always used to say that, das ist der Moment, wo der Frosch ins Wasser springt. Meaning, I don't know, is the moment where the frog jumps in the water. Oh, that's not good. Something is definitely off. Um, okay, but what? Um, what could be wrong here? Okay, all kinds of anxiety right now. What is it? Why did I see some smoke? Was it a bad connection? Just between the connector pin, just at the moment, some arc flashing, or is it some stray uh, ball of solder? Let me see. I see what I did wrong. I can't believe this. What an idiot. This might be hard to see on the camera, but out of all the obvious dumb shit I could have done, excuse my language, I actually placed one of the electrolytic caps the wrong way around. I don't know which camera works better here, but this one and this one, um, yeah, definitely rotated. And with all the talk about using hot air on caps and yesterday in the stream, I now made this moronic mistake, but luckily it's an easy fix. But geez, how yeah, how how can I be this stupid? Let me move this to the side. I'll be using it later. But okay, that's why you, well, I don't know you, but that's why I check, double check, and then still, yeah, make stupid mistakes like this. So let me immediately verify that this did not happen again. Um, see, because the orientation for some of the cabs um, actually changed. I wish my camera focus was better. So C42 and 45 are both facing the same direction here. So positive side on the top. If you look at uh, this build, so the non-DIY build, C45 actually rotated 90 degrees. Um, So it's just good to check this kind of stuff. But in this case, this is not a change in the PCB. This is just a change in the idiot assembling it the wrong way. Move this out of the way. Won't be needing that anymore. Okay. I really can't believe that that I did this stupid of a mistake. Well, made this stupid of a mistake, but I did. So maybe someday I'll do a blooper reel, and this will definitely be be up there. Have to see. Luckily, it's SMD. Getting parts off is relatively easy, but I'll clean this a bit because I want it to stick. Okay, this is not the best method, but it works. It's good to see this, that there's actually some leftover solder paste underneath the component. That's what fried an LM. Ooh, I don't know. Some explosion sound outside. Or the neighbor dropping some heavy some heavy item, but okay, so definitely chuck this solder and replace it with something that is actually fresh, because yeah, I can't have any nasties underneath the components. Okay, for this cap, but it surely will kill any small transistors or diodes, or preheat this pad, add some solder. That's why I never plug in the module and then turn it on. I always turn on the power and then ever so slightly touch the connector, put it in there lightly, so immediately as soon as I see something, I know to pull it out. But yeah, better yet, double check, triple check, do whatever you have to do to prevent just putting the component on the wrong direction, because it might not be an easy fix. It is oriented correctly. The solder seems to flow nicely, even though the board is not 100% flat. But yeah, this will do for now. This could have gone out with a bang. Okay, well, while this cools down a little bit, I don't want any moving components or other surprises. Check this again. Orientation on the other caps seems correct. See, this standoff wasn't fully connected. That touch the side of the board, not a component. Otherwise, you move it if it's still liquid, the solder. Stuff gets pretty hot. Okay, we should be good to go for another round of this powering on. Slightly more anxiety about it than the previous time. I felt pretty confident about the build, but yeah, some of that confidence was gone as soon as I saw that little puff of smoke. Okay, I should actually let this cool down because normally I touch the ICs and the transistors to make sure that that nothing is heating up, but now the board is a bit hot. See if, while this cools down, if I can check the other electrolytic caps, because yeah, now I'm doubting myself. This is correct, correct, correct. So the rest all seems to be a-okay. What is this little ball of doom? I should take a good look at myself rather than this board, but taking a good look at at the board as well. Okay, I'll leave this for now. Okay, next attempt. I wish this cable was a bit longer, but yeah, it's a weird case. Oh. No smoke this time. But also no LED. So what on earth is this now? At least the power supply doesn't get hot. The ICs don't. But also uh, no LED. So it could be that the expansion ROMs are needed for the chip to boot up, but I'm not gonna risk that now. We have -12. We have 12 volts. You know, that's a decent enough start. Just get into some troubleshooting here. Put it on. Well, I'm not sure if this is ground actually. I think this might be ground. Or not. What is going on here? There's a 12 volt. There's something odd going on. Oh wait, this is the -12 volt. So -12 to ground. Ground to plus is 12. Ground to ground should be. See, go to. So this is very, very annoying. Be careful here. The so -12 volt is there. This is rather annoying. See, is there a ground on? This is very odd. Oh wait, this is going through a 10k resistor. And from here to ground. Why are there 3 volts regulator? Um, okay. There appears to be a 12 volts connection to the op amps. Let me see where the other pin is. It doesn't appear to have 12 volts. Probably has 3 volts. Okay, so this is a bit of a mystery. Let's see, did I make a mistake? Where are my LM1117-3.3? As far as I'm aware, this is definitely what I got. Let's check Mouser just to be sure. Yep. See, I've been looking at a wait, maybe check for this ports. Oh wait, it should do Mouser. Come on, Mouser. Okay, it's in Dutch, but we'll manage. 621 dash AZ 1117CH 2 dash 3TRG1. Oh, okay. AZ111 7CH2 33TRG1. Ah, okay. I made a mistake here. Trying to this is a, let's put it on English. So let's see, this is definitely a 3.3, not a negative 3.3. So you could imagine that that is a problem. But then what is my problem here? Yeah, position here. It is this now looks a bit odd with the view. Go back to this U9. Okay. Let's double check those voltages again. It could be actually the little PSU crapping out. I think I had that issue before with the wrong power supply. Let me check. Yes, this is my 12 volt 5 amperes. So that should work. But I did get some power surge uh, with some of the with the other one as well when I used a 9 volt a brick to power it. Which this definitely is a 12 volt 5 amps power supply, so that should not be an issue. Let me go back quickly, look at this data sheet. For sure, this is the 223. Oh, before I pull this out, let me check the bill of materials again. This is I have a SOT 22. So either of these, but should this build have a 39 or 89? Opening my other bill of materials, the Excel that I used to order. Yeah, can how did I end up choosing this 22? Because I think the physical size between a SOT 22 and an 89 is I think there's physically the same size. Let me see if I can make that link between this top pad, which is the voltage in on the 89 and the voltage out on the 22. I think I definitely checked that. Oh, this is my input. Yeah, for sure. And this one as well. So it's not a matter of having the wrong package. Now and then so voltage out should be at the top. Okay, so V out and output. Oh, I have a 223. Which one is this? Oh. Is this an H? An H package or an H2? This is okay, so I can easily check if that top pad is connected to ground, then we're in for a treat. This should be ground. Okay. Then what else could be wrong today? No, wait. Uh, uh, this connected to ground. Then adjust. No. Really. And these two are connected. Okay, so this is definitely, it should be SOT 223/H package. And this is then, so this is an H, and then what I have is an H2. This is, well, that's probably my problem right there. 223. So AZ117. Sure. Oh, there's too many. And can I verify if this is 117H, or this seems to be another H, and then okay. So I definitely let me check this bag of bullshit. See if I can figure this out. So if on that one those two are connected, then on let me see if I can get a data sheet right here. So there's an H, and then this data sheet, pen assignments, just to be 100% sure. Um, so this is ground. So I have an H2, I should have an H. So jokes on me. Okay. Okay, so sometimes you win, sometimes you learn, and I guess today was a learning day. We ordered 10 of these. My next order, uh, continue shopping. Okay, yeah, so I guess that's it for today. Found my issue, wrong type of voltage regulator. I really hope I didn't fry the board, but I'll order this part and then check in later. Okay, thanks for watching. Yeah, uh, this was a bit anticlimactic, but I guess those days happen. See you in the next round.